The integration between Surface and HydroML works via the REST API. So on the left side we have the database with the measurements, surface measurements, that are written by a task on a periodical basis and then sent to the HydroML REST API that take it through the select trained model that's going to run the prediction and return the same content with an extra column informing the result. That's now in this slide identified as label. As you can see in the URL here on the top of this slide, the API endpoint is /API/predict/ the model ID. So one of the models that we have seen that in the screen a couple of slides ago. And the payload is made of the data time on a timestamp in general, plus all readings that you want to get involved in the machine learning training, and finally a label that we can use to understand if this does reflect good data or bad data. The return comes with a similar um, with a similar response, including the label as well. How do we configure the parameterization on the surface side? So for each station, we need to inform what type of model we are using in the HydroML, what are the neighbor stations, what is the target station, what is the data resolution, and the time aggregation. And what does that mean? For rainfall models, our approach is to use the readings, the measurements from the stations that are in the same neighborhood as part of the training model. And in that case, in this screen we can see that we are running a prediction for rainfall, and we have already configured a neighborhood that's composed for X stations, okay, and this set of stations can be reutilized by other stations too. We have a target station, that's the one that this is the station whose data we are going to be using to we want to take it through the quality control. We have information about what is the periodicity of the data and how we are aggregating this data. So one of the aspects of the machine learning model that we're applying here is that it doesn't apply straight away. So the training model doesn't use the raw measurement, but the aggregation over interval of 1 hour. So here is where we identify this information. Then we have information about the labels or the quality control flags lookup table and what that means to the HydroML and to the surface system. So the prediction basically results in zeros and ones, and this is mapping back to surface as a flag bad or good data. In this screen, we can see the scheduling. All this configuration is happening in the admin interface of Surface. So you can see by this standard screen here on the top, this is the Surface admin area. And we do have one task that is configured to run every hour, sending data for the HydroML process. We can see here in the web interface, in the Surface user interface, web interface, how they visualize the results of the machine learning flag. So you can see that on this column ML flag with the results in green, that all these measurements have been sent to the HydroML instance. They were taken through through the model, and we receive the path back into a surface, saved in the database, and now it's visible for the users. Uh, on the left side in blue, you have the quality control, the traditional quality control tests that have not been that are not checked. So the quality control didn't run through these measurements, and that's where we see the advantage of using the HydroML in this scenario. So the traditional quality control tests, they require the definition of a number of parameters on for each one of the stations in the network. This can be time consuming because you want to have a parameter that's as refined as possible, so that you minimize the number of false positives and false negatives. And this is where the machine learning approach uh, comes in, because basically you don't have to create those to define those parameters. Basically, you prepare a training data set where we identify what is good data, what is bad data, and the machine learning model goes through the process of trying to extract from that data set some rules that can be used to classify, to predict data in the future. So this is the first part. This is an overview of what the system does, and we spend a good amount of time showing the surface side of the integration. On the next slides, I'm going to take you through the HydroML interface, show you how to upload a training data set, how to set the configurations with the parameters for the model, run the model, interpret the results, and do a small test running the prediction through the web interface. Thanks a lot, and see you in a bit.